This video is about Lewis structure. You need your notes, a periodic table, and a piece of notebook paper. You're going to be turning that notebook paper in, just so you know. So we've talked about ionic compounds and how, and covalent bonding, and both start with a tug of war for valence electrons between two elements. And if those elements are a metal and a nonmetal, the nonmetal attracts the valence electrons much more strongly. So the nonmetal ends up winning that valence electron tug of war. That forms ions that are negatively charged and they attract. However, if you have nonmetals in a valence electron tug of war, it's a more equal fight. And so they end up sharing the electrons because neither one of them can win them over. And we don't represent them with the dots and arrows like we would in ionic. We have to actually show the electrons being shared between nonmetals. So one example is water. This is a Lewis structure of water, which is 2 H's, 1 O. And the dots and the lines that you see, those are valence electrons. So these lines represent two shared valence electrons between the hydrogen and the oxygen. There's another 2 shared valence electrons here. Some valence electrons are not shared though, so the dots that you see, we call those lone pairs. Those belong to just the oxygen. But no matter whether it's ionic or covalent bonding, all bonding usually ends in a full valence shell for the elements. So what we're going to be looking at today is how to draw these Lewis structures for covalent compounds to show the electrons being shared between the nonmetals. Now, this isn't really what water looks like. This is really more of like a cartoon. There are no sticks of electrons holding elements together. It's really their electron clouds overlapping as they are sharing the electrons. But these cartoons, even though they're not real, they give us a lot of information that can be used to predict the properties of a compound. So we're going to be using these Lewis structures throughout the year. Okay, so when we draw these Lewis structures, remember the goal is to have a full valence shell, which for most elements is 8 valence electrons. So we have to keep that in mind. There are going to be exceptions. We're going to talk about these on Monday. But for today, the goal is to have all nonmetals having 8 valence electrons. When we are doing these Lewis structures, we're basically going to be looking at how many valence electron a nonmetal brings to the compound before it bonds, and then we're going to be rearranging them so that each element has 8 valence electrons after the bond. Now the electrons are either going to be represented as lone pairs, which are 2 unshared valence electrons, kind of like how these are lone pairs. They're not shared, they just belong to the O. They can be represented as a single bond, which is 2 shared valence electrons between the nonmetals. A double bond, so every line you see is 2 electrons, so this would be 4 shared valence electrons, or a triple bond. So I just want to show you some examples of Lewis structures. I just did generic X's and Y's so that you guys can count the valence electrons on each element. So this X, these are finished structures, okay? So this X has 8 valence electrons. There's 2 in this line, or shared bond, 2 here, 2 here, and 2 here. That makes 8. The Y elements also have 8 valence electrons. They have 6 electrons that are not shared, as well as 2 that are shared. So that makes 8. This X has 8 valence electrons, 2 that are unshared, and 6 that are shared. This X also has 8 valence electrons, 2, 4, this line makes 6, and this line makes 8. And then this is kind of a different one as well, so I'll look at this one. Y, this Y also has 8 valence electrons, 2, 4, 6, 8. So that's what our finished products will look like. We want them to have 8 valence electrons. Okay, so let's go through the rules while drawing. So have these rules out to the side. I'm going to be referring to them, but I'm not going to be showing them in the video. I'm just going to be showing my drawings. So the first covalent compound that we're going to draw is CCl4. I know it's covalent because it's 2 nonmetals. Carbon is a nonmetal, chlorine is a nonmetal. So I'm going to show how these valence electrons are shared using Lewis structure. The very first step is to count the valence electrons of each element and what they bring to the compound. So to do that, I look at the periodic table and I see carbon is in column 4A. So before it bonds, carbon has 4 valence electrons. Chlorine is in column 7A. So chlorine brings along with it 7 valence electrons. However, we have 4 of them, so that'd be 7 plus 7 plus 7 plus 7, or you could do 7 times 4, plus the 4 from carbon. So that would be 32 valence electrons. That means our structure has to have 32 valence electrons, no less, no more. So although these are the valence electrons that each carbon and chlorine have before they bond, remember we're going to be rearranging them so that after they're bonded, they have 8 each. Okay, so that's step 1. Step 2 is to determine the central atom, which is always the first element listed, unless it's hydrogen. And we'll talk about why on Monday. So carbon's going to be our central atom. Then we're going to single bond each outer atom, which is 4 chlorines, to the carbon. As we do that, we've used some valence electrons, so we want to keep track of how many we used so that we go over or under our 32 limit. So far we've used 2, 4, 6, 8 valence electrons. We have 24 valence electrons left. So that was step 2. Now we're, 3. Now we're on step 4. We're going to distribute these remaining valence electrons to the outer atoms first so that each chlorine has 8 valence electrons. So currently each chlorine only has 2 valence electrons. And we want to make it have 8. So they need 6 single electrons, which are lone pairs. There's 3 sets of lone pairs, 1, 2, 3. And we're going to be doing that for each chlorine. And if you're keeping track of how many we've used 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay, so now we're out of valence electrons. That is step 1 of being done, but that doesn't mean we're always done. So we are only done with these Lewis structures when we are both out of valence electrons and each element has 8 valence electrons, a full valence shell. So currently carbon has 8, 2, 4, 6, 8, and each chlorine has 8, 2, 4, 6, 8 valence electrons. So we satisfied both of those things, so that means our structure is done. All right, let's move on to a next one, PF3. So never ever skip steps, even if you don't. So don't just start writing your structure. We always start with counting valence electrons. So phosphorus is in column 5A, so it brings 5 valence electrons. Fluorine is in 7A, so an individual fluorine brings 7 valence electrons, but we have 3 of them. So all 3 fluorines will bring 21 valence electrons, plus the 5 from phosphorus. That'll be 26 valence electrons that must be in our structure. No less, no more. Our central atom is the first element listed, P. And then we single bond the outer atoms to the P, which is 3 fluorines. Keeping track of how many electrons we've used 2, 4, 6. We're down to 20 now. Now this is when the electrons are distributed to the outer atoms first, so that each fluorine has 8 valence electrons. So currently each fluorine has 2 valence electrons. They could hold 6 more. So 1, 2, 3, 4, 5, 6. So far we've used 18 valence electrons, and we have 2 left over. Okay, so this is where we have step 4, after we distribute the valence electrons to the outer atoms, if we have any left over, those are the ones that go on the middle atom. So phosphorus will take those 2 valence electrons. We are now out of valence electrons. but remember that doesn't always mean we're done. We have to go back and make sure that every element has a full valence shell, which is 8. So this fluorine has 2, 4, 6, 8 valence electrons. The phosphorus also has 2, 4, 6, 8. So we satisfy both those things. We are done. Okay. Now the next one we're going to do is carbon dioxide. So I would pause the video and maybe start this one on your own, see how far you can get. So pause the video now if you want to do that. Here we go. Carbon brings along 4 valence electrons because it's in column 4A. Oxygen is in column 6A, so it brings 6. But we have 2 of them, so you can say 6 plus 6, or 6 times 2, which is 12, plus 4, gives us 16 valence electrons that must be in our structure, no less, no more. Our central atom is carbon. Then we single bond the 2 oxygens to the carbon. That has used 4 valence electrons total. I have 12 left. Those start to go on my outer atoms first, on the oxygens. And after doing that, I've actually ran out of electrons. So I have none left. But remember, that doesn't mean we're done. We have to go back and make sure that every element has a full valence shell. This oxygen has 8 valence electrons. However, the carbon only has 4. So that means we're not done yet. Now I can't just put extra electrons on carbon because I am out of electrons. But what I can do is rearrange the electrons that are currently in my structure. So what I mean by that is oxygen is being an electron hog and hogging all of these electrons where it could be sharing them with carbon. So what I'm going to do is I'm going to take one of these lone pairs that oxygen is hogging, so that's 2 electrons, and I'm going to make that oxygen share those electrons with the carbon. So I formed a double bond. Now the oxygen still has 8 valence electrons. The carbon now has 6. Still needs 2 more. So I'm going to do the same thing on the oxygen on the left. I'm going to make it share 2 of its electrons with carbon. So now each oxygen has 8 valence electrons, and the carbon also has 8 valence electrons. So now we are done. So some students get too excited to use double bonds. You only ever start to do double bonds and when you are totally out of electrons. So you can't put in double bonds until you are totally out of electrons, but an element does not have its 8. So if you find an element that's unhappy and you're out of valence electrons, that's the only time you should be double or triple bonding. Okay, so that's done with the examples that I'm going to show you. What I want you guys to do is try out SiBr4, CO, so that's 1C, 1O, oxygen, big C, big O, and this is SCl2, so that's sulfur and 2 chlorines. So I want you guys to try these 3 Lewis structures out in your notes. Make sure that you guys are counting your valence electrons and keeping track of them. And then I want you guys to staple your notes together with this sheet. You have the rest of the hour to work on the mixed ionic nomenclature and your Lewis structures, and then turn them into the bin when you're done. Do at the end of the hour.